Hi guys, this is a slightly unusual video, but it was prompted by a question I had from one of my viewers, and I thought it might be worth doing just for interest's sake. It's primarily geared to the Raglan lathe that I have, the Little John, the British lathe. But it occurred to me that there was some things you can do to work out what your feeds are, working out from your gearbox, so you have some idea of what you're getting on cross slide and carriage. So I'm going to use mostly handheld, just to try and explain roughly what can be done. Okay, I did actually make up a chart for reference. Anybody can do this. It might even apply to other lathes, actually, thinking about it. It depends on the lathe in question. But it does at least give some idea of what movement you're going to get under power. Alright, let's make a start. I say handheld, I'm afraid, mostly. Alright. Now, on this machine, if I don't need the lead screw or the power drive, I just pull that gear back, push it back into engagement for threading or power. I've got my handle in the spindle for convenience. This setting here, well, you can see I wrote on that long ago. In the top position, the cross slide comes back, the saddle goes to the left, and down the bottom it's the other way round. Here's my gearbox. Now you might be able to see, I'm not sure, you've got a line here which says A24, then you've got A, B and C 48, and this gear, which I've now got a 48 on, I did have a 24 on there. 24 was okay in as much as it gives you a very fine, you see 60 TPI, but on these scales with the 24 I had to double everything. So if I wanted a, I can't read these numbers very well, not with the camera. If I wanted a 20 TPI, I'd be on B, that position, 10 times 2, 20. Anyway, I'm now getting four normal figures from the 48. Now if I was threading, I'd be using the thread dial, and that's my half nut and gauge. But for power, I've got these settings on here: cross slide and saddle. Okay, but what I was going to demonstrate really was just to show you that by taking some samples and using dial gauges, indicators, you can work out approximately what you're getting per revolution. Alright, I'm set up for one on the cross slide. I'll show you in a moment. Now I'm back here on A30, which on the 48 tooth gear is the finest pitch I can cut on thread. But if we now relate that to the power drive, which is the shaft here at the bottom, I've got a DTI set up on the cross slide. Whether you're going to be able to see the needle, I do not know, but I'm going to take a turn on the spindle. There, I've turned the spindle a few times. It's advancing approximately half a thou. So that's on the finest setting. Right, again the other extreme here for the cross slide. We're on C4. Right, that'll be 4 TPI if we were threading. And now if I go one revolution, if we can see anything on this indicator, That's 1, 2, 3, 4. It's more than 4 thou. Just under 5 thou. Now back on the gearbox. We're on A30. And we've changed the gear yoke to the top position, which should give me carriage towards the headstock. Now this will be quite a lot of movement. Right, let's try and do, okay, you might be able to see the indicator. There's 1 rev, 2, 3, 4, 5, 6, 7, 8. It says 54 divided by 8. So that comes out at 6.75 thou per revolution, and with the 24 tooth idler gear in there we could divide that by 2, which is useful for very fine feeds. But if we now go to the other end of the scale, now for the saddle we're on C4, which would equate to the 4 TPI threading. And this will really get the carriage going. Carriage, saddle, whatever. We try and hold this steady. 1 revolution is going to move this a long way. 50 thou nearly. Basically 50 thou. So that'll be one heck of a coarse feed. But by going through all the gearbox positions and using your indicators, you can come up with a chart. These figures were actually taken with the 24 tooth in, so with the 48 all these figures are basically doubled. And the carriage, whoops, the carriage there, 25, well that was 50, wasn't it? So the thing is, you can work out what options that you have. On the lower end, I think I left this column blank because there was such a small difference on the cross slide, and then the cross slide movement gradually gets more and more significant. So up here that would be 5 nominal. There you go, that's pretty basic. A lot of lathes will have much more information on their gearbox chart, etc. This Raglan lathe is fairly basic, but it is worth knowing what you're going to get out of the power feed, depending on the work that you're doing. Alright, hope it helps maybe 1 or 2 Raglan people. Maybe it gives an idea for other folks who've got a more simple lathe and they want to work out what their feed rate's likely to be. Alright. This is another little add-on, seeing as I'm doing a bity video. Somebody asked me about dimensions on my tailstock cross drilling jig. So just real quick. This block is about 1.25 inches deep. It was made out of a piece of 3.5, probably the biggest stuff I had at the time. So we got 4 studs, and these are 3/8 I think, or 5/16, 5/16 I think. So I've got straps here to hold the work. Max capacity is probably only about 1 inch. These pieces don't normally sit in there because they're not really needed. Once the straps are done up, you're good to go. And there is a hole at the end, both ends, plus a thread. So there's an option for a stop. Right, so the stop can go in there and be locked up and used one end or the other if needed. And the back end is threaded for an M2 arbor. It's an arbor that I made a long time ago. I actually made 4 or 5 blank arbors, but this one I did specially. And that just goes in with it's got a 1/4 inch hole in the side, tightening up. Okay. Some of you have seen this before. Nothing very new, but I was asked about dimensions. These straps are 1 inch by 1 inch 3/16. Not terribly critical. They could be 1 inch 1/4, but these have worked quite well. And I think that's about it. You might be able to see the thread from the Morse taper finishes about 3/8 at least from the bottom of the V. So there's space for the drill to go through and come out clear. Out of interest, this was made. I had an old horizontal mill, but that wasn't set up to be of any use to me at the time. The V was created with a shell end mill in the spindle of the lathe, and had this block set up at 45 degrees and just kept cutting and finished up with a fairly reasonable V. Alright, so that's just a refresher, just to help somebody who wanted to know the dimensions. So just under 3.5 wide, just over 1.25 inches deep. It's a heavy chunk, but it's nice and stable, and on occasions very useful. Well, here's a little extra on cross drilling. I showed dimensions and stuff for my tailstock unit. Hang on, this is slipping here. But in fact, Michael Flager, who, if I pronounced his name right, he wrote me back and said no, it was the unit that Terry Gift made and brought to me so kindly recently. So I'm sort of slotting this in just to give him and anybody else an idea as to what Terry did. And I think I can remember most of what he told me about it. So some of the dimensions are fairly empirical, really, when you think about it. But as a guide, let's start from this piece of 1/2 inch plate, which is altogether 4 1/4, and then the body section here is 2 1/4 nominal. Right, so that is fixed through with cap screws into the barrel. Call it the barrel. And I can't quite see, but he must have radiused inside the contact area there, because it's a hell of a nice fit. Beautiful fit. You might be able to see that he's actually machined away at each end, and from the area that's radiused for fitting. Very nice. Right, other dimensions. So the barrel started off as, well, it's actually 1.1, it's 1/300 there. I forget, it may have started as 1 3/8, I forget. but that's what it is, 1.300, and the length of that's the same as this portion. So the barrel is 2 1/4. Now this collar is a locking collar so that you get the minimal end float. It's a pre-made collar, very convenient. And then if we take this out, I seem to remember that Terry said something about availability of the bearings he had, which is why this is 1/2 inch and 3/8. Alright, this section, well, it's hard to see here actually because that bearing is almost a tight fit on there. This shaft is nominally 5 inch, so both bearings are 1 1/8. Just checking. Yeah, both bearings are 1 1/8. It's been bored through and through, obviously, but the bearing pocket is 1 1/8 each end. This bearing is 3/8 ID, and this one is 1 inch ID. I think what he said was that if he'd had 2 of these, he'd have stayed 1/2 inch all the way through. And what is not very visible, I can't take it out. Where's my scriber? In here there's a spacing collar, and that is about 3/16 thick and inch ID, I imagine, and it's about 725 diameter. So that's that's just a separator to keep the chuck away from the bearing. The chuck itself, I seem to remember, from what Terry may correct me on this, I think he said it's a 3/8 threaded chuck, and I'm not sure what the thread was, but basically whatever the chuck requires you put on the end of the shaft. I'm not sure whether I've left any dimensions out. So I put that back in. Then the retaining collar, which can be cinched up. I don't know what's in there, it could be 1/4 28, not sure. Anyway, it's just a set screw. So having done that up, I've got no end float. Nice free turning. This end of course is for your power drill. That I think is about it. Sorry Terry if I've left anything out. It's one reason incidentally for this shape, it may be self-evident, but the let's see if I can get this oriented. One reason for that finger is so that you can set up in the tool holder with the chuck well back, because obviously one thing you're going to be concerned with here is how much drill length you can get for a given diameter of workpiece coming out of the chuck. But it'll usually be small holes, anything from, I don't know, practically speaking up to 1/4 inch maybe, and with a stub drill that's not going to be a problem. Somebody else mentioned about a thrust bearing. I suppose technically, being pedantic about it, this bearing here could be a thrust bearing as against a ball race. I would say that's nitpicking actually. The amount of pressure that this is going to take with drilling is pretty modest, assuming you're not going to force the drill. So there we are. If there's any query from anybody, put it in a comment, and I'm hoping I've covered all the dimensions just to give some idea. There's a lot of flexibility, but the basic principle of it is fairly simple but very nice. I say this was a heck of a surprise to get from Terry, and I'm delighted to have it. So thanks again, Terry. And Michael, if that helps a bit, you can let me know. I haven't really got time to draw it up in detail, but this gives you an idea of what's been involved. Okay?
Don't groan, it's harbour freight again. Alright, I'm not going to spend long on this. If I can remember, I'll put a link in the description. A guy who made a video, quite a long video in, I think, 2013 maybe it was. And not much has changed. It's basically the same machine for doing your circular saw blades, and I got it. Well, I used a 20% off. Sorry, I'm getting a bit husky in the old voice division. I got it partly for saw blades. This is a new blade actually. I just put it in for demo purposes, but I thought I might be able to also repurpose it. There's a diamond wheel in here, and you can put in a aluminum oxide wheel for steel only, but this is for the carbide, and I won't go into all the setup and stuff, because if you watch the other video that I link you to, it should help. Basically it's for obviously for home use, made for the amateur, I guess. It actually runs very quiet. It's pretty good. The guy who did this other video mentioned several things that could be improved upon, all of which were quite valid, and it's much the same with a lot of harbour freight stuff. You don't pay a lot. I mean, with my discount, even with sales tax, it was about 42 bucks. And I thought, well, if it saves replacing a $20 saw blade once or twice, you've paid for it. But I'm hoping I might be able to modify it for something. If that ever happens, I'll show you. Anyway, I've just dummied it up on here. That's just kissing the blade. These inserts, they're all at 90 degrees, so there's no need to put a slant on it. That's just kissing there. And this little spring-loaded detent takes you to the next position, just to give it a kiss. Not bad. And actually, from a design point of view, it's really fairly clever, I suppose. I'm being a bit generous maybe, but with a few tweaks here and there, it's got the potential. I think it can go up to about a 15-inch disc, but this is my largest, 10-inch, and the other one probably would be a skill saw, 7.5-inch. So there you go. Very quick look. If there's any more feedback on it, oh, that's a little eye protector. If there's any more feedback at another time, or if I do repurpose it, I shall probably describe it. But for now, it's just a case of, hey ho, harbour freight again. Anyway, there you are. I don't think that's bad for the price, to be honest. It would take a long time to make one, don't you think? Alright, this has been a bity video, and I'm just adding an extra final review of what we've done. I did add a bit of finishing at the end of the Raglan lathe feed aspect, so that's pretty much dealt with. But I then went on to describe the tailstock cross drilling jig, which I thought was something that Michael Flager, one of the viewers, wanted to know about. Well, it wasn't that, it was another one. But I did cover that, and I've left it in case it's of interest to people. What he did want was the info on the cross drilling jig that Terry Gift made and brought to me a week ago. So I've just thrown that in. Basic dimensions, just to give some idea. If it's not enough, Michael or anybody, you can ask about it. And then finally, just a quick look at the Harbour Freight. Yes, Harbour Freight again. A Harbour Freight circular saw sharpening gadget, which isn't actually too bad. Make a few modifications and I may try and repurpose it. So that's it. I'm still working on other things at the moment, but this has been a very bitty week because of my bug-ridden body. So I'll put this together and let you have it just as something for the week contribution, and catch you again soon, I hope. Alright, see you later guys. Thanks for watching.